to really take what we've learned from many other parts of the country and to focus on what is that connection between the energy-water nexus and a very important reserve or natural resource for the United States energy future. So let me just close by just saying that the Sustainable Energy Research Institute at the University of Texas at San Antonio is really committed to developing citizen leaders that are dedicated to transforming our energy future. And we truly look forward to a new age where partnering, robust partnerships in these areas associated with the energy-water nexus are critical not only to address the issues here in Texas, but also from an international perspective. Thank you so much.
So if I may, please, those of you that have questions, if you hold it up, some of our folks will collect it, and that way we can assemble these questions together. Let me start with the first question. I think it goes to our first speaker. Ed, one of the audience members wants to know, can you qualify the statement on refrigerator air use that is less water intensive than vapor compression AC? Could you please elaborate on that?
Well, there has been limited studies being done on this, and matter of fact, I'm working with UTEP to see if we can augment, further analysis. There was a study done in Albuquerque with P&M up there a few years ago about that particular area of how much water does swamp coolers use compared to the same amount of energy requirements at a central power plant. And based on that study and based on other limited work, we believe that it is a lot less water utilization. Basically, several years ago, Dr. Tarquin from UTEP did some work for us, showed about 16% of our water is used to cool ourselves, 16% of our annual water. Over 50% is used in outdoor landscaping. That's why we focused a lot on outdoor water conservation. So when you combine those two, you're looking at almost 80%. And as you probably know, less than 1%, probably 0.6% of the water that we treat to very high standards is consumed, for drinking water purposes. So I think further studies will kind of bring more light on that. But I think when you look at all aspects of it, I think going to more of a refrigerated air and working to manage the thermostat and the use of that, just like you manage, water conservation, is the way to go in southwestern cities, as opposed to individual type units on thousands of homes scattered, throughout the city.
Thank you so much. Dr. Shepard, question from the audience, and the answer can't be you get it from New Mexico. Where do you get 45,000 acre-foot of water to support the shale gas production?
Well, I think in reality, clearly it's a great question, and it's one that if you take a systems approach relative to really emphasizing this notion of sustainable development, you can start to work through the inherent challenges coupled with population growth, demands for oil and gas production, demands for agriculture as you look to the future. Today, actually, that's an area where you have a low population density, and we actually have some freshwater aquifers in that region that are readily available and accessible for that kind of flow. Today, I think we're actually looking at roughly 6,000 acre-feet of water. And so the 45,000 acre-feet of water projection is really something that will occur over the course of the next 10 years. I would also say, and at least this is my view, and there are a few experts or those that have been looking at this area in some detail in the audience, that as you start to project out over the course of the 10 years, much like technology insertion has had a profound impact on our ability to recover these gases, natural gases, from these shales over the course of the last 5 years. It's been profound. My expectation is there is so much attention And now we're starting to see increasing levels of investment in technology associated with how to recover these reserves in a sustainable way. That technology will have a significant impact. My expectation is we may reduce the actual projected amount, but more importantly, we may find alternative ways to access these significant reserves of oil and gas other than using fresh water or even brackish water as part of the hydraulic fracturing process.
Les, can I ask you a follow-up question? And the question is, what is the cost difference between the produced natural gas versus the shale? Do you have an estimate on the cost difference?
I don't have a good estimate. Ray, you may have an idea as to what that difference really is.
Depends on the beholder, but I think it's $6 a million BTU for the shale gas. Right now, the price of natural gas is about 4.
Yeah. So the answer that Ray provided was about $6 per million cubic feet versus about 4 on the open market.
Okay. Thank you very much. Richard, there's a question from the group about what about the methane production and CO2 sequestration on a utilization of the deep coal beds?
I guess the short answer is the research group we're at Los Alamos is we have not really looked at enhanced coal bed methane production.
The impact of sequestration of the deep coal bed.
I guess I'll have to pass on this one. I personally wouldn't know enough to. I think I'd be misrepresenting our research group, I guess, if I talked too much about enhanced coal bed methane production. I mean, most of our work at Los Alamos is looking at either enhanced oil recovery or in particular we're doing modeling for injecting in deep saline aquifers. I mean, I know it's not a question, but one of the things we have been looking at and proposing for is not only do we have a lot of water produced through sequestration, we can actually do heat recovery on the water that's produced, and maybe back of the envelope, the heat production from the warm water coming up is enough. The electricity generated is enough to maybe treat the water, to at least upgrade it to either fresh water or to be disposed into the rivers. And so it might actually be energy neutral to treat that water and actually have extra fresh water injected into the system. And so that takes carbon sequestration a little bit closer to being kind of energy or environmentally neutral.
Any of the other panel members would like to elaborate on? Yeah. All right. There's another question from the group regarding the El Paso Water Utility has been a model along the border, especially with Ciudad Juarez, but why so long to capture and scrub methane?
It's a good question. We actually used to do this many years ago. We used to do it. What happened was, first of all, the scrubbers that are available today are much more efficient. When you take the methane out of a digester, an anaerobic digester, it contains other gases, hydrogen sulfide being among them. So you have to scrub the gas and then clean it up before you put it into an engine. Years ago, that process was not that efficient, so you end up with a lot of high maintenance on the engines themselves. So the process has really improved over time. The other thing that happened, aside from that issue, was the price of natural gas has been very inexpensive. It's been very inexpensive for us just to buy natural gas as needed. But now, given the whole energy movement and trying to, use that as a renewable resource, we did receive a grant for about half of our costs. So we decided, it's time to rather than flaring the gas, it's time to do that again. So we'll have those 3 facilities up and running by next April, but it's primarily because of those 2 issues.
Thank you so much. Les, there's a question from the group about what is driving the significant increase in the energy? Is it the industry, population growth, or is it the issue of not enough conservation?
I think the answer is yes. Clearly, as we look out in time, we see significant expected increases in energy demand. A sizable percent of that, about 75% of that energy demand on a global scale, is from those nations, they're emerging nations of the world, who are really trying to move up from an economic prosperity point of view. And they recognize the extreme importance of energy as part of that. Clearly, the issues and challenges around population and population growth, quite frankly, the demographics of Texas in the area in and around San Antonio, when you start to couple that with our agricultural needs and our energy needs, particularly relative to the Eagle Ford Shale, which is an area where we expect to see significant population growth in the next 20 years, there will be natural competition that goes on a local scale. And so I think partly on a local scale it will depend. On a regional scale, it will also vary depending on the type of power you're using, the type of water that's available to you. But globally, I think the general trends will be it's all of the above plus others.
Thanks, Les. Richard, you mentioned something about the carbon cap and storage has some impact on our energy picture. Can you please elaborate on it for this issue of the significant increase in energy when that becomes part of the equation as well?
Sure. I guess I would add to the question is that, I tried to talk about it a bit, is that a lot of these new energy technologies are very water intensive. So in our goal to reduce carbon emissions, we're looking at CCS and biofuels, which are very water intensive, or hydraulic fracking. Also, some of the unconventional fossil fuels, oil sands, oil shale. There are a lot of unconventional fossil fuels out there for us, but they're very water intensive. And so, in addition to looking at growth and industrial pressures, as we move to these new energy technologies, we are seeing we're going to see increased pressures on water withdrawals and water consumption. To emphasize the point I made during the talk is for CCS, new integrated gasification, combined cycle, or the same for natural gas. These new power plants are very efficient in terms of their water consumption and maybe their water withdrawals too. And so from a new technology perspective, that's pretty good. And when you add carbon capture, say, to your IGCC plant, you're not consuming much more water than a pulverized coal power plant consumes today. But the big picture problem is that it's great having these new energy technologies coming on, but we have an existing fleet of power plants that are going to be operating for a long time. And so retrofit is going to be the most likely way to go to be capturing CO2. The most straightforward example would be China. If you look a couple of years ago, they were building power plants at the rate of about 2 gigawatts each week of new coal power plants, and each one of those has at least a 50-year operating lifetime, so they have a carbon footprint for 50 years. So it is great that we have new gasification technologies, other new technologies, but we have to understand that a lot of it is going to be retrofitting existing facilities if we are very interested in reducing our CO2 emissions. And so I think we have to be very aware that we can reduce our CO2 emissions, but it's going to be very water intensive, and that actually might be the limiting resource. And so, we have to come up with better ways to understand how we can do carbon capture and how that is going to fit into this portfolio of low carbon technologies going forward.